This quick video is going to go over an important aspect of writing classes and preparing your objects to be used by other classes available in the Java library. So we're going to talk about how comparison of objects works by default in Java, and how we can actually override some specific methods that are available to every classes in Java, so that when we compare object, we use a specific logic that is object dependent, okay, that we wrote ourselves to ensure that comparison between objects are performed by Java the way we intend them to be for a specific object. So that's going to entail comparison for equality, is an object equal to another, and comparison for ordering, okay, which of those two objects should come first if I had, for example, to use one of the Java library algorithm to sort a bunch of objects in an array, for example. So let's take a look now to the comparison of object in general. So we're going to start with a quick example. So we're going to use a class point. We have here three variables, p1, p2, p3, each of them meant to hold a reference to an object of class point. We create a first object of class point here with a new keyword and applies a constructor that takes two coordinates to it, and we specify coordinate 5 and 3. We create here another point, separate object of class point in memory. We apply the constructor with same parameter 5 and 3. The first reference is stored in p1, the second in p2, and then we say that p3 now holds the same reference as p2, which is going to cause p3 and p2 to refer to the same object in memory. So let's take a look at how this is going to actually look like in memory. So here's a little memory diagram. You can see that P1 contains a reference of a first object, P2 a separate object, okay? These are just so happen to have the same coordinate, but they are different objects in memory. And P3 points to the same object than P2. So let's take a look at how we can compare those objects using the reference variable P1, P2, and P3. So the first comparison that we're going to try to do is comparing P1 and P2. If we write P1 equal P2, it's in comment here because it's wrong, the wrong way to do it. But let's say that we write in our code, we test if P1 equal P2, then what we are comparing here is the value of the reference stored inside of P1 to the value of the reference stored inside of P2. So in this case, each variable refers to a different object, so the value of the reference here and here are different. Therefore, this comparison would tell us false. However, if you look at it from the perspective of are these two objects of class point representing the same point in the plane, well, they do have the same coordinates, so they do represent the same point. So that's actually a problem, right? Second example, let's say that we take P1 and we compare using the equal operator P3. So the same logic is used by Java by default, okay? I look up the reference here, this is a value. I look up the reference here, this is a value. Those two references here, P1 and P3, are different. Therefore, the outcome of the comparison is false. But then again, from a logical point of view, even though these are two separate objects in Java, in memory for Java, this represents the same conceptual point, right? So there is a divergence here between Java, which is just looking at, okay, are those two things referring to the same memory object, and the perspective from the programmer, which might be, well, I want to detect when 2 points have the same coordinate. Unfortunately, the equal statement operator is not going to do that for you. Last example, obviously, P2 and P3. Well, that's interesting because now the comparison is going to result in true according to Java, but not because we have the same coordinate, which is again the semantic aspect, what the programmer wants, just because we have the same reference in P2 and P3. They just so happen to point to the same entity in memory. So if you are trying to determine if two variables reference the same entity in memory, then Java can do that for you for free without you having to do any additional work. You simply use the equal operator and you're done, okay? But if you want something more, if you want actually to say, I want to decide as a programmer of a given class when two objects of that class are to be considered to be the same, to be equal from a semantic point of view, then you have to write you have to write some code, okay? And more specifically, you have to overwrite some methods that are provided by default with by Java, and that act by default just like the equal operator. So we need to use those methods to compare object first, as opposed to using the equal operator. And two, we need to make sure we override those methods so they implement the behavior that we want to compare objects. So let's take an example. The first such method, there are two methods we're going to talk about. The first such method is equals. So we are going to use the example of strings here, okay? If I have a variable str1 and a variable str2, each of them are meant to contain reference to object of class string, spelled with an uppercase S, okay, it's a class name. If I write str1 dot equals str2, well, it's going to use this equals method instead of relying on the behavior of equal. Okay, so it's better to write this than to try to write str1 equal str2. That's my first point. Unfortunately, by default, the way that the implementation provided to you by Java of the method equals work is just going to look at the reference here and the reference there and tell you whether those references are the same. So pretty much it's going to tell you, just as the equal operator did, whether you're talking about the same entity in memory, the same object in memory. So that's not going to go, okay? But that's the default behavior. Now, the good thing is that we cannot change the way that the equal operator behaves, but we can definitely override this method. Okay, we can override this method for which we have a default provided by Java in all of our classes. Okay, even if we don't write the method equal, it's there, it's provided by default with this behavior. Well, we can provide our own version. So this is what we're going to do. Okay. The second method now that is of interest when you're trying to change the way that things are tested between object, I mean the quality of object, how it is tested, and the comparison of object, which one comes before the second one. The second method that is relevant to that kind of task is compareTo. Okay, so equals is just going to give you a Boolean outcome. It's going to tell you yes, no, true, false. These two objects are the same. compareTo is a little bit more fine-grained, okay? It gives you more information. It applies a concept of order between the two objects you're trying to compare, and it's going to tell you whether the first object comes first, whether the two objects are equals, or whether the second object comes first. So there are three possible outcomes, okay? And just like the equal method, there is a default implementation that comes with Java that is present in every class that you write, even if you don't write, compareTo. You can override, just like is the case for equals, you can override this implementation to make your own logic apply here. And just like equals and compareTo are methods that are so so fundamental to the Java collection framework that everywhere in the Java collection framework, when you have to order a list, like sort a list, for example, or something like that, the Java collection framework is going to expect that your classes that you wrote and that are meant to be sorted or ordered in collections, etc., are featuring correct version of those methods. So it's really important to hear about these methods early on, okay, and be aware of their role. So, for example, in the string class, the string class also featured this method compareTo that allows it to return those three outcomes. So they are encoded as integer value, okay? The return value of compareTo is going to be negative when you call it with a dot compareTo another reference to another object b. It's going to be negative if object reference to by a comes before object reference to by b, using something called the lexicographic ordering. So in the case of string, you can think alphabetical order, but that also takes into account weird symbols like underscore, etc., and also takes into account uppercase, lowercase letters, okay? So it's just kind of like an alphabetical order on steroids, okay? So if the outcome of this comparison is that A must come before B, then the return value is going to be an int that is lesser than 0. If A comes after B, then it's going to be greater than 0. If A and B are considered equal, according to this lexicographic ordering, then the return value is going to be 0. Okay, so we are illustrating compareTo. We can implement compareTo on our own object, and we'll do that. But right now we're illustrating it on the class string because it's easier to understand it at first contact, of the class string, because we all understand what the alphabetical order between two strings is. Okay, so it's not a special case, it's not complicated. It's very a nice leeway into understanding how compareTo works. So how do we use compareTo? Okay, we saw that convention about 3 different return value. Okay, so let's say that we have a first string Alice here, a string object Alice. Reference to this object is stored in a variable A. Another string object in memory named Bob, containing Bob, sorry. And the reference to that object is stored into a variable B. So when we call A.compareTo B, and we are going to test whether the outcome is lesser than 0, equals 0, or greater than 0. Okay, in this case, A compared to B lesser than 0 would be true. All right, so this table here kind of summarizes for you how you would use the compareTo method between two objects that are referenced by variable A and B, okay, in comparison to how you would use the comparison, how you would perform the comparison on two primitive data types. So to fix things, let's say that A and B are, like in our example, two variables that are meant to hold reference to object of class string, and A and B in this column here are, for example, int. So if A and B were two int primitive data type, you would write A lesser than B to test that A comes first. Well, the way that you write it between two strings is A compared to B, and you can see that the lesser than sign here is oriented the same way. So that makes it easy to remember what you are testing, okay? If you are testing A compared to B lesser than 0, you are testing A comes before B. So the analogy continues between int and strings, throughout this table. Lesser than equal would be lesser than equal. So it's either A comes first or A and B are equivalent. This is a strict equivalence. This is A and B are not the same. This is B comes first or is equal to A, and this is B comes first. Okay, so you see this is a very easy way to remember, how to use that compareTo return value. And then another thing that is interesting is what is the relation between compareTo and equals. So if you are returning a 0 when you call compareTo, that means that a call to equal should return 0 as well. And I'm using should on purpose here. You're going to see why in a second. So testing that two ints are the same, this is how it's going to be done. Testing that two strings are the same, that's how it's done. And this is equivalent to calling A dot equals B, which would return true. Anything else? Okay, any of those cases here, those 5 cases would return false if we were calling equals between A and B. All right, so that sounds easy, that makes sense, okay. So why do we even bring it up? Well, what if you have actually a difference in the behavior between compareTo and equals? Let's say that in my own class, okay, I implement a compareTo that allows me to compare two objects of class, let's say employee. Okay, I have a class employee, one of the field is a salary, and when I write compareTo, I look at the salary of the object referenced to by variable A, I look at the salary of the object referenced to by variable B, and let's say that I put A before B if A has a greater salary than B. Okay, so I want to be able to sort those objects of class employee based on the salary. So we'll talk more about that when we deal with collection, okay? But it's just a simple example here to introduce a concept first. So let's say that I implemented compareTo, but when I implement equals in my class employee, either I make a mistake or I have some other purpose in mind. For example, when I use equal, I want to compare the employee based on their employee ID. So I'm going to say that two employees are the same only if their employee ID is the same, or two employees are the same if the first name, last name, and date of birth matches in both objects. Okay? Well, here's the problem. We have a notion of equality here that is not compatible with the notion of ordering that we apply to our objects. The ordering is based on salary, the equality is based on something else, okay? So Java is not going to prevent you from writing this kind of code. but it's not really recommended. It's not recommended in the sense that if you want to take your class, if you want to take object of your class employee and have them, stored in a Java collection, sorted maybe, stuff like that, well, the Java collection is going to assume that compareTo and equals behave the same. So you need to be really careful about when you decide that suddenly you don't want those two methods to be compatible with one another. As a matter of fact, if you decide to do that in one of your class, there is even like default language that is recommended for you to use in the documentation so as to warn other programmer that you're doing something a little weird here. So here's the recommended language, not this class has a natural ordering that is inconsistent with equals. Okay, so keep that in mind, be careful. You can safely assume that any of the basic Java classes are going to behave in a manner where equals and compareTo are compatible with one another. When you write your class, you could, on purpose or accidentally, break that equivalence. If you do so, that could be a source of bug, okay? And if you did it on purpose, definitely make sure that you document this fact, okay? So as I said several times actually throughout the video, this video was just about introducing the concept of, it's not trivial to compare two objects. You should certainly not use equal. You should use dot equal method or the dot compareTo method. And if you do so, you can rely on the default Java behavior, which is it's kind of like it's arguable that that's going to be relevant because it boils down to the equal operator behavior. But more interestingly, you can override those default behavior and implement your own version of how to compare two objects of your class. Okay, and we'll talk a lot more about this when we deal with collection, but for now I just wanted you to have the concept actually clear already in your mind.